In this video, we're going to look at how to graph a system of inequalities. So first off, let's just talk about inequalities and how to graph one inequality. And so we've got the names of our inequalities here: less than, greater than, less than or equal to, greater than or equal to. Now, when we have an inequality that's less than or greater than, the side that's smaller cannot be equal to the other side. So for less than, whatever's on the left, let's just say x is less than 3, we know that x cannot be equal to 3. Otherwise, we would say less than or equal to. So we're going to be graphing and then shading our inequalities here. And when we have less than or greater than, we have to put a dashed line, because that represents that there are no points on the line that fits in the inequality. If we pick a point on the line and use that value in our inequality, it makes the inequality false. But if we have or equal to for either of our inequalities, then we use a solid line, because any point on those lines are true in our inequality. And now when we think about shading based on our y-axis here, so our y values going up or increasing that are larger, they're going to be up above, right? Because the positive direction on our y-axis is going up. So if something is greater than, we shade above, okay? And then if something is less than, we shade below that line. So a couple more things here before we actually look at the graphs. So when we're actually graphing the system, graph both inequalities, figure out if it's not in slope-intercept form, convert it to that so it's easy to graph. Or if you don't want to convert it, you can just graph the intercepts and connect those 2 points. Then we want to shade our inequality. Make sure we've got our solid or dashed line, but shade above or below. And then wherever we have an overlap with our shading, just make sure to darken that so we know exactly where our solution is for our system. Okay, and that overlap is called the solution or feasible region. So let's say we've got these two inequalities here. The first one's already in slope-intercept form, where y is by itself, and that's our blue line here. So we graph that. Notice how we've got a slope of 1 and a y-intercept of 1. So if I had to graph this, I do my y-intercept there, up 1 to the right 1, up 1 to the right 1, and then same thing, down 1 to the left 1. So there's my first inequality, and it's a solid line because it's less than or equal to. And then my green one, let's say I don't want to convert to slope-intercept, I just want to graph it from the way it's written here. I can do my x and y-intercept. So for my x-intercept, I know that y has to be 0. So I substitute 0 in for y here, and then it's basically just x greater than -2. But when I'm trying to find the intercepts, I'm kind of thinking of this as an equal sign. So that gives me an x-intercept of -2 right here. And then for my y-intercept, my x value is 0. So I basically take the x term out, and 2y equals -2. Remember, I'm just trying to find the intercept here. Divide by 2 on both sides, and we get y equals -1. So my y-intercept is -1. So I got a point here and here, and I can tell from that my slope is -1/2, because I go down 1 and right 2. So I just continue that to create the rest of my line. Since it's not or equal to, I have to do a dash line, and now we just have to figure out where we shade. So for the first inequality, I need to, I'm going to shade in blue here. It says y is less than or equal to x plus 1. If it's less than, that means it's below, and on my y-axis, positive numbers are going up, negative numbers are going down. So if something's less than, I want to decrease it. That means it's going to be below my line here. So shade below. Notice how there were 4 quadrants, or kind of 4 sections here that my lines created. So I'm trying to figure out which of these 4 overlaps for my solution. So I'm guessing green is either going to be shaded down here or shaded above here. So one of these 2 sections is going to be my solution. So now with this one here, now it's a little easier to shade when we have slope-intercept form. So that's another advantage to graphing it that way. But I can just leave this here, and there are a number of ways I can figure out where to shade. Okay, I can just quick do in my head, like if I were to get y by itself, is this sign going to stay as is, or is it going to flip and become less than? I know I don't have to multiply or divide by a negative number to get y by itself, so it should remain y is greater than, okay, which means I would shade above here. But another thing I can do is I can just take any point that I see. Usually it's going to be easy numbers like 0 or 1, and I substitute it in and see if it's true or not. So I see the origin 0, 0 is just above my line. And that's where I'm guessing I'm going to be shading because it's greater than. So I'm just going to plug 0, 0 in to my inequality. And see if it's true. So I get 0 plus 0, which is just 0. And 0 is, in fact, greater than -2. So the point 0, 0 is in my solution for that second inequality, the green one, which means I am shading above. Okay, and so now I see that this section, let me get my highlighter here. This section right here is overlapping with the solution from both inequalities. And so this is my solution to my whole system. Any point in this shaded area fits into both inequalities. So any of those points would be a solution to my inequalities. One other thing to remember are the points on the lines. So any point along this dashed line here, those are not included. We do red. Those are not included in my solution because it's dashed. It's part of this inequality that's not or equal to. So those are not part of my solution, but anything on this solid line here that's touching this overlapping shaded region would be part of my solution. So my solution is all the points in this shaded region and on this little section of my solid line. Okay. Let's look at one more example that's already set up, and this is horizontal and vertical lines. So sometimes we for the most part with linear equations or inequalities, you're going to have some diagonal lines there, but every once in a while we get a horizontal or vertical line, so the shading might look a little different. So in this case, x is less than 1, so then I graph right at x equals 1, so that's that vertical line going through my x-axis at 1, but it's less than, so it has to be a dashed line. And now I got to think about with my x values, well, positive numbers or bigger numbers are to the right, negative or smaller numbers are to the left. And so if my inequality is x is less than, then any point to the left of my line is going to be part of the solution for that specific inequality. Okay. So notice how in this case, I can't shade above or below because I have a vertical line. So in this case, it's to the right instead of above, to the left instead of below. My horizontal line, that one's a little easier to do. X is less than or equal to -4. Well, less than is going to be below. So this bottom left section here is my overlapping area. So anything in this area that's touching my solid line, but not my dash line, that is, so this part right here is okay. This part right here is not okay. All right. I'm going to do another video with some other examples, some non-linear functions, so square root and absolute value, so check those out.